Series means in a line. Parallel means, well, parallel to each other. Components behave differently whether they're in series or parallel in a circuit, so we're going to take a look at those differences. Here I have two circuits, both containing 3 identical lamps and both containing a battery at 6 volts. The 6 volts just tells us that each unit of charge that goes through the battery collects 6 joules of energy to take round the circuit. I have another video explaining voltage, current and potential difference, so I'll leave a link to that in the description. In the series circuit, the charges have to travel through all 3 lamps before going back to the battery to collect more energy. That means a unit of charge will drop off 2 joules at each lamp, assuming they're all identical, and then back to the battery for another 6 joules. The voltage across each lamp is therefore 2 volts. And notice that the voltages in a series circuit all add up to get the total voltage supplied. In the parallel circuit, each charge will only go through one of the lamps before returning back to the battery to get more energy. That means it'll drop all its energy off at one lamp. So the voltage across each of the lamps is 6 volts. Each unit of charge will drop off 6 joules of energy as it goes through a lamp. Well, what about current in a series circuit? Well, current is the rate of flow of charge, or putting it another way, it's the amount of charge passing a point per second. In a series circuit, the charge has only got one way to go. It'll flow all the way around the circuit and back. That means the rate of flow is the same everywhere, all around the circuit. It doesn't sort of get bunched up anywhere as it goes round. So in a series circuit, the current is the same all the way around the circuit. In a parallel circuit, the charges have got a choice of which way to go. So the current, the rate of flow of all the charges, it kind of splits up. Some of it goes through one component, some of it goes through another, and therefore the current divides. In a parallel circuit, the amount of current in each branch of the parallel circuit is the same as the total current coming down. They've all got to add up to the same value, the value supplied by the battery. Let's now look at some examples. What's the missing voltage and what's the missing current? Well, the missing voltage is 12 volts because each branch of the parallel circuit, the voltage needs to be the same. The missing current is 1.5 amps. That's because 1.5 amps add 1.5 amps is 3 amps. The total current flowing in the circuit doesn't change, so the current through the 2 branches, well, that's got to add up to the total current. Here's one more. What's the missing current and what's the missing voltage? Well, this is a series circuit. Out of the 12 volts that are supplied, 6 volts are dropped across the first lamp. That leaves 6 volts to drop across the second lamp. Remember how the voltages have all got to add up to the total voltage supplied. So 6 volts and 6 volts equals 12 volts. In a series circuit, the current's the same all the way round, so it has to be 0.75 amps wherever you measure it. Here's one last final one, where I combine both a series and parallel circuit and try and catch you out. Before I do that though, can I point you in the direction of my website, VideoPlatoAcademy.com. On there you'll find lots more free resources, there'll be links in the description. I also offer one-to-one lessons myself, the links to that will be in the description as well, and there's revision courses as well, all at a great price. Here's the last example then. What's the missing voltage and the missing current? Well, 1 amp is flowing from the battery down through the first lamp, and then it splits. The current splits to go through the 2 different lamps. Half an amp will go through each lamp, so the missing current is 0.5 amps. We know the total voltage is 12 volts. 8 volts is dropped across the first lamp, so how much is left to drop across the parallel part of the circuit, the 2 lamps in parallel? Well, that's got to be 4 volts, because 4 volts add 8 volts is 12 volts. In all these examples, I've assumed that the lamps are all identical. If we change the resistance of the lamps, that changes things a bit. So bear that in mind. There's some worked examples with questions on my website, linked in the description below. But now, once you've liked and subscribed, watch this.